Okay, let's give you guys some more practice. So looking at this area, looking at this area from 0 to 2. So looking at this area here, which would give me the bigger volume. Me rotating it along the me rotating it 360 along the y-axis, or me rotating it 360 along the x-axis. So looking at this area here, will it give me a bigger volume if I were to rotate this 360 along the y-axis, or will it give me a bigger volume if I were to revolve this around around the x-axis? Okay, so which would give me the bigger volume? Okay, so looking at this area from 0 to 2. Okay, so so press pause and have a go. Okay, so let's try and do let's try and work out the volume by rotating it along the y-axis. Okay, so we could sum up all the disks, but I think this method here is a lot harder because you would need to know the radius here, and then you would have to rearrange it to make x a subject here. It is quite hard. In this case, it might be easier to use to sum up all the cylinders. Okay, so looking at one particular cylinder, the thickness associated with this cylinder here. Remember, this is going to be 360 along the y-axis. Okay, so the thickness here will be dx. So really, we are summing up all the cylinders from 0 to 2. So from 0 to 2, and then the circumference of this thing here will be 2 pi r. But r, remember, x is moving along here, so the radius happens to be wherever x may be. So the circumference here will be x. And then so this here will give us the circumference of this cylinder, and then we need to know the height. The height of this cylinder here is given by this. So it will be us multiplying it with 4 this root x to the power 3 plus 4, close it off, dx. Okay, so we are summing up all the cylinders from 0 to 2. So if you revolve this around the y-axis, the volume is given by this. Okay, the volume is given by this. So now just evaluate this volume. So rewrite it like this. This gets multiplied to the top. 8 pi is a constant. Take it out, and then integrate this bit here. And then we need to integrate this bit here. But visualize this thing here as this thing multiplying this thing here. Okay, that's to the power of minus a half. Well, visualize this whole thing here as this. So now to integrate this, just notice that when you differentiate this, it gives you what's on the outside here. Just bear that in mind. Okay, so to hang on. So to oops, bear with me. Hang on, sorry. So to integrate this, bear with me. So to integrate this, hang on. So to integrate this here, we are looking for something. We are looking for something that, when we differentiate it, it will give us this thing here. Well, let's just zoom into this bit here. Let's make our guess to be. So remember, we are trying to integrate this. So our eyes will zoom into this bit here. So it will be x to the power 3 plus 4. Make our initial guess to be 1 higher than this. So that will be a half. Okay. So let's make this to be our initial guess. So when we differentiate this, it will give us a half. The bubble stays intact, and then the bubble gets the power here gets minus by 1, and then we've got to times with the derivative of the bubble itself, which will be 3x squared. You see, this here almost matches up with this. This here matches up with this. we don't need this half here. Let's negate it. So if we were to do this, make our adjustment to be 2, and then so when you differentiate this, it will give you this thing here. Okay, and now we don't need this 3 here. So let's times this by a third. Okay, so this here, so when you what you got a third times 2 here, so that will be 2 over 3. Hang on, let me tidy this up. That will be 2 over 3. 2 over 3. So when you differentiate this, it will give you this thing here. Okay, well, integrate this, it will give you this, and then evaluate it. Yeah, and then evaluate it, put it into here, and then take away so this, take away this, so that will then give you this, and then blah blah blah, and then the answer is this. Okay, in the next video we're going to rotate it along the x-axis, but for this video, rotating it along the y-axis, it will give you a volume of 24.53. In the next video we're going to look at it rotating in the x-axis. Okay.